Okay, so today we're going to do some collisions, some virtual collisions. And this is a picture of the table that we're going to fill in for our masses, our velocities, and our momentums for both the red car and the blue car. As you can see, there's before collision and after collision. There probably should be a line drawn down the page roughly right. Oops, that's not my pencil. Right about here to distinguish between before collision and after collision. All right, so let's start off on the simulation website that's linked in the document, the assignment. To make this bigger, you can click right here on the upper left-hand side. And now we're going full screen. Now, we can change the mass of the red car by clicking on this picture of the red car with the bricks. We can go 1, 2, or 3 kilograms, and same thing with the blue car. We can change the velocity, the initial velocities of the red and blue car using the arrows. We can have it at rest, and it'll stay at rest, or we can have it moving left with a negative velocity, or we can have it moving right with a positive velocity. So if the red car has a positive velocity, it'll go this way. If the blue car has a negative velocity, it'll go to the left, and they will collide. So if we hit start, we will see that collision. All right. Now the type of collision is at the bottom. We have elastic, inelastic, and explosion. All right. I just did elastic, and they bounced off each other. If I do inelastic, and set red positive, blue negative, and I hit start. The inelastic collision is when they stick together. That's 100% inelastic. All right, so let's just do an example calculation for an elastic collision where the blue car is at rest. Notice I can change the position of the blue car by holding down and dragging it. Let's set the blue car's velocity as 0. The red car's velocity at 4, and let's make the red car have a small mass and the blue car have a big mass, and let's see what happens. So let's press start. This is elastic collision. Okay, it bounces off the blue one, and they both end up going opposite directions. Let's use this information to fill in the table that I was showing you earlier. So we had the red car at 1 kilogram and the blue car at 3. All right, let's go to our screen. So the red car had a mass of 1 kilogram and the blue car had a mass of 3. The initial velocity before the crash I had at 4 for the red car and 0 for the blue car. Notice for the directions it says that the initial blue car velocity to 0, set the mass values to different values, right, which I did. The masses are different, 1 kilogram versus 3 kilograms, and then run the simulation. So after the collision, right, this arrow right here, it's actually facing the wrong way. It actually was going that way. So it had a velocity of -2 meters per second and for the red car and +2 meters per second for the blue car. So momentum is always conserved in both inelastic and elastic collisions. Let's go ahead and do the math to show that. So let's follow the red car all the way through. Okay, we'll do that first. So the red car was 1 kilogram before and after the collision. The velocity before the collision was 4 meters per second, and after was -2 meters per second. All right, we're calculating momentum, so momentum table, and momentum is mass, right, which is right here, multiplied by velocity. So we get 4 kilograms meters per second, 1 times 4. After the collision, 1 times -2, we get -2 kilograms meters per second. Change in momentum, right? Change in momentum is final momentum minus initial momentum. So if we do the math here, we have -2 minus 4, and we get -6. So the momentum change for the red car was -6 kilogram meters per second. All right, so the momentum of the red car decreased, but what we should see is that the momentum of the system never changes. Let's do the math for the blue car. All right, so the blue car was 3 kilograms. Initial velocity was 0. Final velocity was +2. The initial momentum, so the momentum before the collision for the blue car was 3 times 0, which is 0. And the momentum after the collision was 3 times 2, which is 6. Okay? Final minus initial. 6 minus 0 is an increase of 6. So the blue car's momentum increased by 6 kilograms meters per second. All right, so the red car had a decrease, the red car had a decrease, the blue car had an increase, right? The total momentum of the system, if we go down the chart, right? If we go down the chart, before the collision, the total momentum of the system was 4 plus 0, right? Which is 4. That would be the blue car plus the red car. After the collision, the momentum was -2 plus 6, red car plus blue car, which again is 4. So as you can see, the momentum from before to after did not actually change. Individually, it changes, right? It shifts from, from some of the momentum in the red car shifts to positive momentum in the blue car. But the overall momentum of the system, the change in the system, is actually 0 kilograms meters per second if you do final system momentum minus initial system momentum, you get a change of 0, or did not increase or decrease.